So the ratio of the lengths of two sides of a right triangle is called a trigonometric ratio. So now we're looking, remember I told you, now we're looking at sides and angles and how they're related. So the three most common ratios are sine, S-I-N-E, everybody say sine. Okay, cosine, C-O-S-I-N-E, everybody say cosine. And tangent, everybody say tangent. Okay, so when we abbreviate sine S-I-N. So when you see S-I-N, do not say sin, it is sine. When we abbreviate cosine, we abbreviate it C-O-S. Do not say cos, it is cosine. And then tangent, of course, is abbreviated T-A-N, and it's tangent, not just tan. Okay, so let's just make sure that we know sine, cosine, and tangent. They're not sin, cos, and tan. Got it? All right. Now, here is what I do need you to write. Your first card is going to be the sine function and how you find the sine function. So take a few moments to write this down. Okay, so a lot of times you will see on like in books or in different things that you read, or even especially next year when you move on to physics, because physics is this part of geometry is heavily related to physics and pendulums and things like that. How this says the sine of A, the sine of A and the sine of B, they are specifically talking about angles, but I'm going to let you know that a lot of times you will see the theta symbol, which looks like this, much better than that, right? And they're going to say, oh, theta is this. This is just referring to an angle. Okay, so they refer to angles as Greek letters. So they might say the sine of theta is equal to 12. I mean, it could be something like that, right? And so theta is talking about that angle. So that's something that you want to be knowledgeable of so that when you see it, you don't forget. So right here, when it says the sine of A, that means your reference angle is angle A, right? And so the sine of A is equal to the opposite over the hypotenuse. So the opposite is going to be the side that is opposite A. So across from A would be the opposite. And then, of course, the hypotenuse is always going to be the hypotenuse. Is never going to change. It's always across from the right angle. So the sine of A is going to be the opposite over the hypotenuse. So basically now you have three things that you don't know. You don't know the measure of angle A. You don't know the length of the opposite. You don't know the length of the hypotenuse. But you can find either of the three if you know two. Okay, you can find either of the three if you know two. And so that's kind of what we're trying to figure out today. Like if they give us two pieces of information, then if they give us the opposite and the hypotenuse, then what's the measure of the angle? And that's something that we haven't been able to figure out before because they haven't told us. Or if they give us one angle in one side, then we can figure out the other side because that's information that they haven't told us before. So if we're talking about the sine of A, then here's our opposite over here. Here's our hypotenuse. But that switches up if we're talking about the sine of B, because here's B right here. And so then if we're talking about B, then our opposite moves to over here because that is the side that is opposite of B. But my hypotenuse is going to stay the same. Does that make sense? So you always have to have a reference angle to figure out what your opposite is, what your hypotenuse is. Well, your hypotenuse you will always know, but what your opposite is and what your adjacent is, which is what's coming up next.
What's the best way to choose your reference angle?
Oh, it depends on what information you have. That's a great question. So you're going to choose your reference angle based on the information you have, or you're going to choose which function you use based on the information you have. And I'll explain that a little bit. It'll make a lot more sense in a little bit, but let's say they give you A, right? But you only have this angle. I mean, you only have this side and this side, right? Then you can't use the sine function. And in reference to A, then this is actually what's called adjacent, which we're going to do for cosine. And so then you would use a different function. So just based on your information, it's going to determine whether or not you're going to use which function you're going to use based on the information that you're given. And once you see all three functions, then I promise it will make more sense. All right, so let's look at an example of using the sine function. All right, so draw this picture and we're gonna use, okay, this is what I need you to do on your notes. I need you to draw this picture like over to the left, and then I need you to leave space on the right because we're gonna come back to this same picture for the other functions, okay? So we're gonna reference this picture 3 times. Okay, so the first thing that it asks me for is the sine of L. So I'm trying to make sure I stay consistent with the colors so that can help. All right, so here's L. Right? And so if this is L, then I know this 12 over here is my opposite, right? And this, of course, is my hypotenuse because it doesn't change, right? So then the sine of L is going to be 12 over 37. Make sense? Okay. Then I'm just going to go to the next slide, but the picture's going to stay the same. Then it's asking me for the sine of N. So then here's N, right? Oops, sorry, y'all. Here's N, right? So if this is N, then here is now my opposite for N. My hypotenuse doesn't change. So my sine of N is equal to 35 over 37. Make sense? Okay. So keep this picture in your head because we're coming back to this same picture after we write our next card. Okay? All right. So now let's look at the cosine function. So same picture, but now different ratio. Cosine now has the adjacent and the hypotenuse. So I'll give you a moment to write that down and then we will look at it. Okay, so now cosine introduces us to adjacent. Okay, so now we can take a triangle, and if we have a right triangle, label all the sides, because whatever your reference angle is, you're going to use that reference angle to figure out what is opposite of that adjacent, or what is opposite of that particular angle, and then what is adjacent to that particular angle. And then from there, now you can say, oh, I'm going to use cosine, or oh, I'm going to use sine, because you know what's opposite, you know what's adjacent, and of course we always know what the hypotenuse is, because that's always, of course, the easiest. So your cosine is going to be the side that is adjacent, the ratio of the adjacent side and the hypotenuse. So we are going to go back to the same triangles, right? This is the same one we just looked at, okay? And in the beginning, we first talked about sine. We had the sine. Try that again. So we had the sine of L is 12 over 37. And then we had the cosine, then we had the sine of N, right, is 35 over 37, right? So now let's talk about the cosine of L. And so here's my L. So 12 is going to be my opposite. 35 is now my adjacent, and my hypotenuse has not changed. Okay. So then the cosine of L is going to be adjacent over hypotenuse, which is going to give me 35 over 37. And then the cosine of N is going to be, now if this is N, then my adjacent now becomes this 12, and my hypotenuse stays the same. So I've got 12 over 37. Okay. And so I wanted to have both of these on here so that you could see how they're related. Do y'all see what I'm talking about? Pretty straightforward, I think. Okay. What you finna say? Nothing. Okay, let's keep going. We got one more function to learn. So let's get that out there. It's our last card. And that's the tangent function. So I'll give you a moment to write down tangent. Then we'll talk about it. Then we'll put all three together. Okay. All right. So tangent's the last one. And tangent is going to be your relationship between the opposite and the adjacent. So basically, you have three sides, and you can set up, for what we know right now, three different ratios: the sine, the cosine, and the tangent. Okay. So let's look at some examples. All right, so we're back to the same problem. Remember, I told you we're gonna look at it 3 times. Okay, so on the first one, we're talking about L. All right, so here's L. As soon as they let me get it. So here's L. All right. So if this is L, then this is gonna be my opposite. This is gonna be my adjacent. Here's my hypotenuse. So I'm gonna have the sine of L is 12 over 37. The cosine of L is 35 over 37. And now I'm looking at the tangent of L, and remember, tangent is opposite over adjacent. So that's going to be 12 over 35. Then when I'm looking at N, here's now my opposite. Here's now my adjacent. Hypotenuse doesn't change. So I've got the sine of N is 35 over 37. The cosine of N is 12 over 37. And then the tangent of N is 35 over 12. Okay. All right. So now that you know all three, how are you going to remember? Right? There's 2 different ways, and I want you to pick whichever method is best for you. Some people can remember SOHCAHTOA, right? So if you can remember SOHCAHTOA, then you have the sine is opposite over hypotenuse, the cosine is adjacent over hypotenuse, and the tangent is opposite over adjacent. Okay? And that will help you remember if you can remember SOHCAHTOA. Some people, like me, are spelling challenged, and that would cause a problem for me. Spelling is not my thing. I'm a numbers person. And so you can write ho-ho, like, almost like Santa. Put an A at the top and an A at the bottom. Yes, ma'am. Mia. Okay. having a slow moment. Hold on. Okay, dashboard. Is she a Duncanville student or no? Okay. What's the last name? Okay. Juliano. Yes, she applied. Let me see. Let me find her name. Yes. Uh-huh. Okay, sorry, y'all. Okay. Yeah. Oh, okay. So if you have, can you find my, okay, so remember I wrote ho, I put an A at the top, A at the bottom, right? And then it's gonna be your trig functions in alphabetical order, so C, S, T. So another way that can help you. So either one of those will help you to remember which one you're supposed to do and how you're supposed to do it, okay? So just a little hint for that. All right, so let's keep going. All right, so a fitness trainer sets the incline of a treadmill to 7 degrees. The walking surface is 5 feet long. Approximately how many inches did the trainer raise the end of the treadmill from the floor? So we are trying to find in this particular image the value of y, right? Okay, so I know this angle here is 7. So because I know that that angle is 7, then, because I know that that angle is 7, then that's going to be my reference angle. Okay, that's going to be the angle that I use. So if I'm trying to find y, what's the relationship between this 7 and the y? Y is the opposite of 7, right? Okay. And then, of course, 5 is going to be the hypotenuse. So the two pieces of information that I have are the opposite and the hypotenuse, which means I'm going to use the sine function. So the sine of 7 degrees is going to be equal to the opposite, which is y, over the hypotenuse, which is 5. Okay. And so now I can solve this like a regular equation. The sine of 7 is a number. You don't split it up. You do not split it up. So in order to solve this for y, I'm going to multiply by 5 on both sides. Okay. And so now I have that 5 times the sine of 7 is equal to y. And then this I'm going to take and put it in my calculator. Now, here's the unfortunate thing. Mr. Thompson took all my calculators because he swear he needs them for Algebra 1 because they have a STAR test, blah, 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 whatever. But if you take the calculator that is on your phone, there's a couple of things you have to be sure of. The first thing is, let me unlock my screen. You could take it and turn it sideways, and then that will give you your functions. So now I can see sine, cosine, and tangent. But we're talking about 7 degrees. So you definitely want to make sure that, I don't know, I have an Android, y'all know. And so I can see in the corner, I see RAD, which stands for radians. And I can tap that and change it to degree, which is DEG. So it says that on mine. And since I'm talking about degrees, I definitely have to do that. And so then once I change it to degrees, and I can put exactly what I see, 5 sine of 7, and push enter. And then I'm going to get that y is equal to 0.609. Okay, so you definitely want to make sure that you have your calculator in the right mode. And I try to make sure that I get like enough calculators, and you can also use your computer. You can just put it in the search. It'll come out for you as well, but you have to make sure that you are in degree mode if we're talking about degrees. And we haven't talked about radians yet, so we're definitely going to be in degree mode, okay? All right, questions?
So you don't know which function to use based on what they give you.
Based on the information that you have, yes. Definitely based on the information that you have. All right, last card for the day. Last card for the day. Clear this off. And where's my mouse? Oh, yeah. Oh, I'm on the wrong thing. Okay. So this is your inverse trig function. This is kind of small to me. Let's see what I can do to make this a little bit larger. I just made it a little bit larger. All right, so your inverse trig functions are what's going to help you find the measure of the angles. So I'm going to give you a minute to write it down, and then we'll talk about it, and then we'll be done for the day. I feel like I've been doing a lot today. What you have with inverse trig functions is, let's say they give you the sides of a triangle, and you need to find the measure of the angles. This will help you find the measure of the angles. Because realistically, it's a right triangle, and the only thing that we know in a right triangle is that there's a 90-degree angle, right? But there's an infinite number of possibilities for the other two angles, and if we know the lengths of the sides, then we can figure out the measures of the other two angles. And inverse trig functions, so like sine inverse, tan inverse, cosine inverse, those are all, that's the calculator will do it for you. So it is nothing you have to do, you just have to be able to set it up, and once you set it up, the calculator will get the number, okay? So don't make it harder than it is. I promise it is not that difficult, okay? So you're still gonna use the same ratios when you're looking at inverse trig functions. So that will be easy too. So let's look at an example, okay? You know what? I feel like these calculators, let me see, I can't even remember. I think the calculator on the phone might not even have inverse trig functions. Let me see. Oh, it does. Mine does. So when I turn it, I have an inverse button, and I can tap inverse and it'll show up. Okay, so let's look at it, because I'll tell you what to do, how to put in your calculator. It says use the calculator to find the measure of angle P to the nearest 10, right? So here's P down here at the bottom. P's right here, right? Okay, that's I feel like that's hard to see. Okay, so 13 is what relation to P? 13 is the adjacent, right? Right next to it. Here's the 19, the other piece of information that I have. 19 is opposite the right angle, so it is the hypotenuse, right? So if I have adjacent and hypotenuse, I know that I'm using cosine. So the cosine of angle P, because that's our reference angle, is equal to the adjacent 13 over the hypotenuse, which is 19. Okay. Okay, so remember I told you cosine of P is just one number. So you can't split that up, right? So if I'm needing to find P, then here's where I'm going to do the inverse function. So I'm going to do the cosine inverse of just 13 over 19. And that's going to get me the value for P. The cosine inverse of 13 over 19. So I'm going to put that in my phone, cosine inverse of 13 over 19. Make sure I'm in degree mode, push enter, and I end up with, it says round to the nearest 10th. So 46.8 is equal to P. The 46.8 is equal to P. So that means this angle down here is 46.8. So what would be Q? What will be Q? What would be Q? Not quite. Huh? Almost 43.2. It's okay, I did it in my calculator. So Q would have to be 43.2 because those two angles have to add up to give me 90 because it's a triangle, a right triangle. All right. I'm tired now. Questions? All right, that's it. That is it. That was a lot. It seemed like it took us a long time, but we did it. Y'all did it. Good job.